Okay, in this video we'll summarize block diagrams with an example. So what are block diagrams? It is a way to represent information flow in a control system. So we'll consider an example which we all are familiar with. Consider the activity of taking a bath under shower. Here our objective is to get a comfortable bath. For this we need to make sure that the temperature of water is same as the desired temperature or within a range of desired temperatures. Now let us consider a block diagram representation of this problem. So we have a desired temperature. For a given configuration of the knob, the temperature of the water is the actual temperature. The desired temperature is set by our brain, and from our common practice we know that for an unknown configuration of the knob we don't directly get under the shower. Instead what we do, we touch the water with the help of our hands or legs. In terms of block diagrams, that can be represented as the measurement of the actual temperature by the skin and providing an output to the brain. Now here the information by the skin to the brain is not exactly equal to, may not actually be exactly equal to the actual temperature. It gives an information regarding the measured value of the temperature as sensed by the skin. Now the brain has information regarding the desired temperature and the measured value of temperature. Depending on the difference between these two temperatures, the brain has to take a decision. But the decisions of the brain cannot directly affect the knob position. Instead, we need another block which would affect the knob position and ultimately the actual temperature. As we may have guessed, this is nothing but our muscles or the limbs. So the brain gives an output in terms of desired knob position to the muscle or the limbs, and the muscles and the limbs give the output as the actual knob position. Now the change in the knob position brings about a change in the mass flow rates, in the temperature of the actual water, and these are all characterized by the piping system. So a change in the knob position would bring about the change in the flow rates, and hence which comes under the consideration of piping system. Hence our ideal block diagram would look like this. But in real life application we face certain disturbances to our piping system. Consider two consecutive bathing units. Now if a bathing unit is adjacent to one which is under use, we normally from our common practice know that the mass flow rate of the water would tend to decrease, and so on. So these all considerations come under disturbances. Hence we have solved the problem of representing the action using block diagrams. Now we can generalize for a control system the general block diagram as: we have a reference, we have a control output, the reference is set by the controller, the control output is initially measured using a sensor, and the sensor provides an information to the controller in terms of the measured output, which may or may not be exactly equal to the controlled output. It depends on the sensitivity and the accuracies of the sensor. Now the controller has to take a decision via another body, which in previous case were muscles and limbs, and in general control system this is nothing but the actuator. So the controller gives the output and input to the actuator as the desired control input. Now the actuator gives the output as the actual control input to the plant, which are in the previous case was the piping system. The plant now gives the actual control output, and this would be the ideal case, but again there are disturbances to our plants. Now we summarize the importance of a block. So a block transforms an input variable to the output variable, and this completes our discussion on block diagrams. Thank you.